We'll find the inverse of a trigonometric function the same way we've found inverses of any function in the past, and that is beginning by switching x and y. Remember, f of x is just a fancy y. So I'm going to begin this problem by switching those around. So I'll say x equals -5 times the cosine of 2y. And then my goal is to get y by itself. So again, we'll do this the same way we've done things in the past. So I think I'll begin by dividing both sides by -5. So then I've got, I'll just do negative x over 5 is equal to the cosine of 2y. Now everything is, or the 2y is kind of trapped in that parentheses, so I need a way to get rid of the cosine in this case. Well, hopefully not surprisingly, to get rid of a cosine, I'm going to do the inverse cosine of both sides. So the cosine with your little -1 symbol on it. When I do the inverse cosine of cosine, those just cancel out. My new equation is looking like this. I've got the inverse cosine. I'm going to put negative x over 5 in parentheses just so I can see that that's all grouped together, is then equal to 2 times y. So at this point now I don't need those parentheses and I'm almost done. To get y by itself, I'll go ahead and divide both sides by 2. So that would sort of be what one answer would look like. Y is equal to inverse cosine of all that over 2. Or, I mean, that's fine. It's a little weird looking. What I might do instead of dividing by 2 is I might just multiply by 1/2. So my equation looks a little less messy if I do that. 1/2 times the inverse cosine of negative x over 5 is my inverse equation. Remember, equations need equal signs, so I'm going to go ahead and put equals. You could do equals y if you want to, that would be fine. Since it's an inverse, if you want to be really fancy, I'm going to do this. So f with the little -1 symbol of x, just to kind of represent that this is the inverse function of what I began with. So that's finding the inverse function. There was one other part to this problem, though. They also wanted me to state the domain of the original function and also the domain of the inverse function. So let's go ahead and do that. The domain of f, the original function, is actually really easy to do. If you recall what the graph of a cosine looked like, that was just that wave that went forever left and right in both directions. Since domain describes where the graph goes left and right and the cosine waves goes forever left and right, my domain is just -infinity to +infinity. I can plug in any number that I want for x. Okay, so that, I mean, and that's always going to be the case because we're only doing sines and cosines in this part. So that part's not bad. The part that gets a little bit trickier is finding the domain of the inverse function, so the domain of the inverse of f. And there's an easy way to do this, and it actually does not involve anything to do with your actual inverse function. Rather, I want you to think of this problem in this case. So let's go back to the original problem and actually find its range. And you're probably thinking, well, why do I care about finding the range of the original problem? They didn't ask me to do that. Well, remember, when we find an inverse, everything just switches around. So by finding the range of the original, I'm actually finding the domain of the inverse at the same time. So a little kind of sneaky way to do this problem that makes it a lot easier to do. The reason I say it's a lot easier is going again back to that original function. To find its range, we just need to think about how high and how low that function goes. Well, we're not going to actually graph this, but if you think about what you would do to graph it, thinking about how high and how low this graph goes, well, since we just finished graphing, that should be an easy question for you. Remember that amplitude number, as well as the midline if you have one. This one doesn't have a midline that's been that's moved it up or down. So that amplitude is going to tell me my graph goes up to a maximum of 5 and goes down to a minimum of -5. It's just the amplitude. So that again, that's the range of the original function, -5 to 5. And I'll use square brackets because I can actually get to those points. But because we want to know, because we're working with an inverse, this range of the original becomes the domain of the inverse. That's how inverses work. So my domain of the inverse is the same thing as that range, -5 to 5 with square brackets. Those are the values of x we're allowed to plug in the inverse function. I think a lot easier way to do it than trying to mess with this down here, because that does get a little bit messy. So I think I've got all my parts figured out then. There's my inverse function. There is the domain of the original function, -infinity to +infinity, and the domain of my inverse, -5 to +5.